In the previous video, we saw how working with some identities from 5.5 allow us to factor more efficiently. And the one we saw was that when we have a plus b times a minus b, that's a squared minus b squared. And we essentially look at this identity the other way around to be able to factor more efficiently. So this is the identity you want to use for factoring. The first one is the one you want to use for multiplying. So we saw that one, but there's another one in 5.5 that we can use, and this is the one I want to introduce here. Another identity, and I'm going to write it so that it can be used to factor. And what's this identity? Well, actually, let me start with what's on the right of the identity. It's when you have a plus b that's squared. Well, we saw in 5.5 that this is equal to a squared plus 2ab plus b squared. Furthermore, we also saw that if it's a minus b instead, there's going to be a minus here. So we've got sort of a single identity here, okay, that regroups two very similar identity, one with a plus sign, the other one with a negative sign, and we can use that to factor. So that's called we're going to say that this is a perfect, or it's factoring a perfect squared, because we can express it as something squared. This is really a perfect square, just like 9 is a perfect squared because I can write it as a product of two integers. So that's the idea here. Okay, so let's look at some examples. If I have x squared minus 2x plus 1, okay, if I can see that the term in the middle here is twice the product of the square root of this one, which would be x, and the square root of that one, which would be 1, okay, then it's not exactly the square root, but what I mean is that this is x times x, so there's an expression that can be squared to give me back x squared. Maybe that's better. And the 1 here, that's 1 times 1. So if I collect this term and this term, and I see that the one in the middle is twice the product of x and 1, that means it's a perfect square. So that's the case here, right? I'm in my head, I'm seeing, oh, this is actually 2 times x times 1 plus 1 squared. This is the way I see the previous expression. You wouldn't write this in your solution necessarily, but this is what needs to happen in your head. You're like, oh, this is 1 squared. This is x squared. This is x times 1 times 2. Oh, bingo. So this side is really of the form a squared minus 2ab plus b squared. So that's a perfect square. So that's going to give me a minus b squared. So that's going to give me x minus 1 squared. So of course, all this part, that's happening in your head, okay? So it's this part that usually we write down in our solution. We say, oh, x squared minus 2x plus 1. Oh, that's x minus 1 squared. It becomes easier with practice. It sounds complicated right now, but once you get used to it, you can recognize perfect square pretty easily. I'm going to leave some space underneath each example. I want to revisit them using techniques from earlier sections. So let's say I have x squared plus 6x plus 9. So here's what's going on in my head. I'm seeing this as, oh, this is x squared. This is 3 squared. So immediately, I guess, I tend to think that maybe this is a perfect square as soon as I see that the first term is something squared, the last term is something squared, and I'm just checking, if by chance, the middle term is 2 times the x times the 3. And it is here the case, right? 2 times x times 3. that's indeed 6. So because of this, right, I'm seeing this as a squared plus 2ab plus b squared. So that's going to give me here a plus b squared. So that's going to be equal to x plus 3, all that squared. So of course, when I write my solution, I only write this part, but what's below is all what's happening in my head, all the reasoning that I do to get to the answer. So again, I'm going to leave some space here just to come back to it. Let's say I've got 4x squared minus 20x plus 25. So you see the 4x squared? I'm like, oh, that's actually 2x squared. 25, that's 5 squared. So if maybe by chance the middle term is 2 times the 2x times the 5. Is it? Yes, it is. 2 times 2 times 5, that's 20. So that means I'm in a situation where I've got a squared minus 2 times a times b plus b squared. So I know that this is going to give me a minus b squared. So that's going to give me 2 minus 2x, which is my a, minus the b, which is 5 squared. So once again, I would only write this part in my solution, but what's below is all that's happening in my head to get to the answer. Maybe one with 2 variables. If I have this, okay, so again, I'm tempted to think, oh, maybe this is a perfect square because I'm see this 64. I'm saying, oh, that's 8 times 8. The 100, that's 10 times 10. So you see, if you don't know your multiplication table, right, the calculator will be useless here, right? Because if you can, it's only going to be useful if you know what you need to do. And if you know what you need to do, it's because you've recognized that you've got like perfect squares for your coefficients. The other thing though is that I've got these minus signs, right? So normally I don't have minus signs to apply my identity. My identity is related to this, right? But I don't have minus signs here and there, right? So it seems like I won't be able to use it. However, I've got a plus sign here, so actually I can take out, so to make these plus into plus signs, maybe I can take out a negative sign, and that's what I'm going to do now. So there's just extra difficulty, and on top of having 2 variables, there's this extra difficulty where I wanted to show you that sometimes you can take out a minus sign before seeing the what's inside as a perfect square. So with the minus sign taking out, oh, I'm like, oh, this is 8x squared. This is 10y squared. And maybe, if I'm lucky, this is 2 times 8x times 10y. And let's check, right? 2 times 8 times 80. That's 16 times 10. Oh, yes, 160. So I'm good. So that's going to give me 8x minus 10y squared. Times the minus sign, right? So my final answer is here, right? Right there. So let's just go back. Sometimes it's difficult to recognize you've got a perfect square. Like the first example is, I mean, this one you probably have to know by heart. So if you see this, you sort of have to know, oh, that's going to be x plus 1 squared. Okay, it's the most obvious or the most famous perfect squared. And if you see this, you have to kind of even know by heart that this is x minus 1 squared. But if you've got like examples or problems that are similar to the other examples, then sometimes it's difficult. You don't see that's a perfect square immediately. I want to show you how, if you don't see it's a perfect square, that means you're going to apply another technique, and that other technique is the AC method, or just finding the factors of C if the coefficient of x squared is 1. And I want to show you how that turns out. So if I apply the other method, you see I'm gonna have that my product is c. C is 1 here, and my sum is the coefficient of x is -2. So I'm looking for a product of 1, sum of -2. So product of 1 means both numbers are either positive or negative, but because the sum's negative, both are negative. It's very easy to see that the two numbers I'm looking for are -1 and -1. Now you see I have exact same numbers, right? -1 and -1. So when you see this, you know you had previously a perfect square. Let me show you why. So if you've got -1 and -1, you see the polynomial you had, it can be factored as x plus the first number times x plus the second number. And that's really, what's this? The second number is still -1, right? X plus -1. So you've got x minus 1 times x minus 1. So you've got twice the same number, which means you've got twice the same factor, which means it's the factored square that you get ultimately. So when you have the same numbers here, you have a perfect square. Okay, let's take a look at maybe example the third one. Okay, so here I don't have a coefficient of 1 in front of my x squared, so I'm going to have to apply the AC method. See, so this is the other technique. Or let's say I didn't see that was a perfect square. I'm going to say, oh, my product is a times c, so it's 4 times 25, so 100, and my sum is the b, which is -20. So okay, now I've got to look at the factors of 100 and see if I can find factors that multiply to 100, so they're both positive or both negative, and sum up to -20. So that means I know they're both negative now. And those two numbers are -10 and -10. And you see, oh, I've got twice the same number, so that means I had a perfect square. And let's take a look at how that goes. So with those two numbers in hand, I would split my middle term. No, it's -10 and -10, so split my middle term. -10x plus 25. I'd factor by grouping. Take out a 2x, so 2x minus 5 here. And if I want a 2x minus 5, I need to factor out 5 here. I get 2x minus 5. And finally, I take out 2x minus 5, so I'm left with, oh, bingo, 2x minus 5 again, and that means it's 2x minus 5 squared. But as soon as I saw these, I knew I had a perfect square, okay? So it's actually up to you. So you can either, once you get those two numbers, maybe you can do all this, but maybe you can say, oh, actually, let me go back and think of my polynomial in this way. So this way you can factor more efficiently, actually in one step, because you know it's going to be a minus b squared. Okay, it's going to be 2x minus 5 squared. The a is the 2x and the b is the 5. And the same could happen in the other example. I'm not going to go through it, but but actually notice that it's going to be a bit harder here. If I have to work with -64 plus 160xy minus 100y squared, you see the AC method would give me what, a product of a. Oh, there's a next square here, I forgot. So a times b times c. So you see I'm gonna get a pretty large number and a sum of 160. So you better be good with factoring here, because you were working with really large numbers. It's possible to avoid this slightly. I could always, you know, because I have already even numbers, maybe I can take out a factor of 2. If I do this, you see I get -32 plus 88xy minus 50y squared. I still have powers of 2. Actually, I could have taken out a 4 at the beginning. So I take out another 2. I've got -16 plus 40xy minus 25. So already the numbers have gone down a bit. If I forgot my x squared. So working with with this instead. I could try to factor that instead, but I'm still working with pretty big numbers. See, product of minus 16 times 25, right? That's 400. Is it 16 times 25? Yes, correct. And sum of 40. So, and then you have to know your numbers well. I know that 20 times 20 is 40 and they add up to 40, but I just saw that, but I don't know how good you are with factoring. So you see, if you always rely on the AC method, sometimes it can be pretty difficult. While if you recognize that you have a perfect square at the beginning, oh, this was a lot faster, right? So these shortcuts, they're, I mean, you can always avoid them, but if you do, you're going to spend more time and problems are going to be harder than they were initially. So I recommend working on these, and at least in the exercises that you're going to solve in that section, you're sort of guaranteed that one of the identities is going to be used. So make sure you practice a lot.